In this video, we're going to explore hypothesis testing for the variance and standard deviation. Now, if you remember when we did the confidence intervals, we used the chi-square distribution when we looked at standard deviation and variance. That will be the same here as we do hypothesis testing. So, like other problems, we first need to find our critical values for the rejection regions. And to do that, we need the level of significance and the degrees of freedom. Then we need to determine is it left, right, or two-tailed problem. And then we use whichever formula is necessary based on Excel 2010. Now, let's look at two examples. Say that I want to do a left-tailed test when my alpha is 0.1 and my sample size is 14. So left-tailed, I just plug alpha directly in and I do n minus 1 and I get 7.042. That means my rejection region will be from 0 to 7.042. Now say I want to do a two-tailed test, alpha of 0.05 and sample size of 23. I got to do a left-tailed and a right-tailed chi-squared. The biggest thing to remember is that when I do my alpha, it's alpha divided by 2 since it's a two-tailed test. And that'll give me these two values. I plot them and shade on the extremes. Now if I want to do a hypothesis test using the chi-square test for either variance or standard deviation, the steps are going to be very similar to what we've been doing before for the other hypothesis testing. I need to state my claim, my null, my alternative hypothesis. I need to specify that level of significance and the degrees of freedom, and I need to create my critical values and rejection region. Now the one thing I've got to pay attention to is when I actually create my test statistic from my sample. Because depending on whether I'm doing variance or standard deviation, that'll change whether or not I need to do anything with these two values. Because if you remember, s squared is variance. So if I'm given variance problems, I plug it directly in. But if I'm given standard deviation, I have to square these values because the standard deviation squared is my variance. Let's look at two examples. So this first one, Campbell's Soup claims that the variance in their label height is 0.26. And you want to test it with 38 cans and find the variance is 0.28. Is that enough evidence to support the company's claim at 0.01? So the claim is that the label height is less than 0.026. Since it's less than, the claim will fall in the alternative hypothesis, where the null hypothesis is that it's greater than or equal to 0.26. So since it's less than, I'm going to be doing a left-tailed test. I plug in the alpha and then it's my sample size minus 1 and I get a critical value of 19.96. Now when I do my chi-squared test statistic, I'm dealing with variance, so s squared is the sample variance. I plug it directly in. Sigma squared is the claims variance, which was 0.26. Plug all these values in, I get 39.85. Now if I plot that on my graph, I see that that is not in the rejection region. So I failed to reject the null hypothesis. So at the 1% level of significance, there is not sufficient evidence to support Campbell's claims that there is less than 2600's variance in the label heights. In comparison, let's look at this problem where I'm looking at standard deviation. So KFC claims that the standard deviation and wait time once ordering is 22 seconds. And I do a random sample of 47 customers and find that the standard deviation is 27 seconds. And at 0.05, is that sufficient to reject the company's claim? Their claim was that the wait time standard deviation is 22 seconds. So that's an equals versus not equals, so that is a two-tailed problem with the null hypothesis being the claim. So first thing, I'm going to find my left and my right chi-square critical value since it's a two-tailed problem, and I plot them. Next I'm going to find my chi-square statistic, and this time I will have to square each of these values because it's standard deviation. Standard deviation has to be squared, and I get 69.29, which falls in my upper rejection region. So I will reject the null hypothesis. So what that means is that the 5% level of significance, there is sufficient evidence to reject KFC's claim that the standard deviation and wait time once ordering is 22 seconds.